Hello everyone, welcome to this session. In this session, we will be discussing ICSE Grade 10 Computer Applications Theory paper, and we will be focusing on the questions which are based on method overloading. What is method overloading? Method overloading is a concept in which a class has more than one method with the same name. Then how are these methods differentiated from each other? By the parameters. Now, either the number of parameters or the order of parameters or the data type of parameters should be different for method overloading to work properly. Okay, or in simpler words, the method signature has to be different for method overloading. So let us look at three examples which are problems from either the specimen paper or past board paper and try to solve problems based on method overloading. In method overloading, two concepts are being tested. One is the concept of method overloading and second is your basic programming concepts using loops, if, and so on. So let us look at this example over here, which is asking us to define a class to overload the method print. Name of the method is print. There are three occurrences of the print method. The first print method has 0 parameters. The second one has 1 and the third one has 2 parameters. Okay, so let's go on and implement this class. It's a new class. They have not mentioned any name of the class. So in that case, what we would do is give the name of the question. So question 4, okay. Edit the class, delete everything and start. Most of the programs, we start by writing import java.util.scanner. Method overloading, generally we don't need it, but no harm in writing it. We then come by starting the class and implementing the methods which are mentioned. There are no data members mentioned, so we don't need to write any data members. The first function or the first method is void print. The prototype has been mentioned. Prototype is the first line of the method. Void print, curly bracket, and in this, we will have to write the functionality. What they want is a pattern, which is a triangular pattern, right? In pattern programming, we have to decide, okay, we have to decide R, which is the number of rows, which in this case is 4. Okay, we have to decide C, which is the number of columns in each row. Now, the number of columns here, the first row has only 1 column, the second row has 2 columns, third row has 3 columns, and so on. So here the number of columns in each row is dependent on row. It is not a fixed value. Third thing we have to decide is value to be printed. Now, sometimes in some pattern programming, the value to be printed is dependent either on the row or the column. But in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it is a pure sequence that is being printed. So the value to be printed is a separate value. And based on this, let us start writing our pattern program. Pattern program is always a nested loop program. The outer loop is for the number of rows and the inner loop is for the columns. So we start by saying int v, the value which we are going to print, initially is going to be 1. Fine. The outer loop is for the number of rows. So r is equal to 1. First row, second, third, and fourth. So we start with 1 less than equal to 4. And every time we will go on increasing the row number. This is followed by the loop for the columns. In each row, how many columns do we want to print? So we again start with by printing the first column. And we mentioned here that the number of columns in each row is dependent on the row. So which is the column should be less than equal to row. And then we have C++. This is the inner loop. In the inner loop, we will be printing the value, and do note it will be a system.out.print because we want to complete a row on one line. Right? So here we are saying, what do we print? We print v, which is the value, plus a space. Okay. And once we have printed 1, we want to change the value of v to become 2. So our inner loop will have these statements. After one row has been printed, after all the columns in one row have been printed, what we want to do is take the cursor to the next line. So hence, we will write here system.out.println, just an empty println to take the cursor to the next line, and that completes our row loop. Okay, and that completes the first method in method overloading. Okay. Moving on, the second method, the prototype given is Boolean print int n. Okay, and we start the curly bracket. The word Boolean over here means the return from this method is going to be a value of type Boolean. Okay, it is not a void method. The value here will be a return of type Boolean, and the functionality that they want is to check whether a number is a Dudney number. When it is a Dudney number, if the cube of the sum of the digits is equal to the number itself. So the example given is 512. The digits are 5, 1, 2. So sum of the digits, which is 8, cube of 8 is 512, which is equal to the original number. So this problem statement belongs to a category known as digit programs. Okay, programs where you have to extract the digit of the number and then apply some logic to those digits. So let's start here. We say Boolean int n. N is the number which is going to be passed, and this is the number which we have to check. So what we will do, we will make a copy of this number and save it in some original number. Digit programming has a fixed formula, we can say. Okay, so what we say, while the number is greater than 0, we have to go on extracting the last digit and then reducing the number. So how do we extract the last digit? We say int LD. LD stands for last digit. You can call it anything, but this will remind you it is going to extract the last digit. So we say int LD is equal to n modulus of 10. N modulus of 10 means it will give you the remainder of a number when you divide it by 10. So suppose we take the number 512. So what 512? If we do a modulus of 10, the remainder, the quotient will be 51. The remainder will be 2. Okay, this is how. So in the first occurrence, it will give us 2 as the number. LD, last digit of that number, can get extracted. And then the next thing you do is you change the number to n is equal to n divided by 10. This means I am changing the number. So now for this example, 512 divided by 10 is number 51. Integer division in Java programming, if both the numerator and denominator are integers, the answer output will also be an integer, which is 51 in this case, because we have already taken care of 2. Fine. Now this will give us the last digit. What do we want to find? We want to find the sum of the digits. Okay, so in that case, the program is always going to do a cumulative sum. Cumulative sum means you found a digit, add it. Found the next digit, add it. So here I also need to make, okay, I can make this a comma, sum is equal to 0. And what do we write here? We say sum is equal to whatever is the existing sum plus the new last digit that we have extracted. And this while loop will continue till it has finished extracting all the digits from the number. Okay, we can just follow this just to understand what is happening. So here 2 was extracted, number changed to 51. Original sum is 0. So right now it will be 0 plus the last digit is 2. So the sum is 2. I go on top and I check, is n greater than 0? N is 51, still greater than 0. So I will extract a last digit again. 51 modulus of 2 will give me the last digit, remainder. Okay, the remainder is going to be 1. The quotient in this case will be 25. 51 divided by 2, 25 will be the quotient and 1 will be the remainder. We change n, so n will become whatever was the original n, 51 divided by 10, which will be 5. Okay, Sum will become existing sum, which is 2, plus the new last digit, which is 1. So the sum will become 3. Last example again, we again go up and we check, is n greater than 0? N is 5 right now. 5 is greater than 0. So we will go inside the loop for the third time. And here it will be 5 modulus of 10. When we divide 5 by 10, the quotient is 0. Okay, integer division, quotient is 0. Remainder is 5. Okay, and then we do 5 divide by 10. Okay, that was modulus. Now I'm dividing integer division. The answer will not be 0.5. The answer will be 0. Moving on to the next step, sum is equal to sum plus LD. Existing sum is 3. 3 plus, again, the last digit extracted is 5, which is 8. So the sum, when we come out of this number, is 8. When go on top again, we check, is n greater than 0? N has become 0. So now this condition is false. So we will exit the loop and reach. Now the thing they want to check is if the cube of the sum is equal to the number itself. So it's a condition that we are checking. So we say if. Now cube would be, I can just multiply. So sum multiplied by sum multiplied by sum is cube. If I use the math.pow function, it returns a double and then I will have to typecast it to an int. So we can use this for now. Sum multiplied by sum is equal to the cube of the sum. Is it equals? Equals operator is 2 equal to. Is it equal to the original number? If it is equal to the original number, this function should return a boolean. So we will return, okay, true. Else we will return false. Indentation in Java is optional, but do try to indent it a bit so that your programs, when they are written on paper, are very clear to the examiner. Okay. This is how we can solve the second method, which is related to digit programming. The third method is, the prototype is given, void print. Third method over here, int a char ch. Functionality required is if the char ch is a small s or capital S, we should print over here. Again, it's a void function. So we will print the square of the number. Else we will print the cube of the number. So it's a simple check. If ch double equals for comparison is equal to small s or ch is equal to a capital S, what will we do? If there's only one line, we don't need curly braces. So we say system.out.println. What do we want to print? The square of the number. Which is the number given here? This int a. A is the input number over here. Okay, so I will print a multiplied by a, which is the square of the number. The other thing is, we can write else if, but make sure that you will check. It has to be C. So we have to check again if ch is equal to a small c or ch equals a capital C. Then we have to print the cube of the number, system.out.println. And we will print the number is a multiplied 3 times is the cube. And that completes the third method. And since they have not asked us to write a main method, that completes the class as well. Fine. So do note, first method says print. It is a void function. It says print. Second method, the return type is a boolean and the word over here is check. It is not saying print the result. Okay. Third method again is a void and it is saying print the square of the number, else print the cube. Okay. So we can just compile it and the class has been compiled. Fine. This is problem. First example of method overloading. We'll look at another example of method overloading. Okay. Same concept, class to overload a method number as follows. In this case, two methods have been given. This is also called number. This one is also called number. And what is different? Number of parameters are different. First method has 2 parameters. Second method has 1 parameter. And they have even asked us to write a main method to create an object and invoke the above methods. Fine. So let's get started. We'll make a new class. This is example 2. Since they have not given us any name of the class and I do not have the question number here, you can give it a name. And then we take this and start. We have the import java.util.scanner followed by the class example. Start writing our methods. First method prototype is void number, 2 parameters, takes a num input and it takes a d as an input, which says count and display the frequency of a digit in a number. So if the number was 2565685 and the input d was 5, we will say 5 occurs. Frequency means how many times that number appears. So 5 appears in this input number 3 times. Okay, so this is a count and display function. Again, we are working with digits, so the logic will remain the same as in the previous example. Here we are counting something. We are counting the frequency of the digit. So in any counting programs, we make a variable called count. And because it is going to be adding values, the first initial value of count will be 0. Okay. Number programming or digit programming, how do we do? We have a while loop. While that num, here it is, num is greater than 0. Extract the last digit, int ld is equal to num modulus 10. And we change the number also here directly. You can also write num slash equal to 10, which is the same as saying num is equal to num divided by 10. Okay. Now we have extracted a digit. In this example, remember it will be the last digit, which will be extracting 5. We have to check if that is equal to the number that we are looking for. So it will be if the LD that we extracted equal to the digit that the user is asking us to find, then what we will do? We will do a count plus plus. That means we will increase and say, okay, found 1 occurrence of that particular digit. Okay, and this will end the while loop. So if you have looked at the previous example, you know how the loop will work by going on extracting the rightmost digit, changing the number. And in this case, what do they want us to do with the digit? Just compare it with the input digit and increase the count. Once the while loop is done, I can then print the count. Let's say system.out.println. And the message they want to give is frequency of digit. Okay, so I'll say frequency of digit. What digit? Digit is what was input here, D. Okay. Variables come without quotes. Text comes in quotes. Is equal to the count. That completes the method. So as I mentioned before, in method overloading, they are testing how you write the same method prototype. And secondly, they will be testing some programming logic based on loops, based on conditions, okay, or pattern program, series program. The next example, which we will look at, is series program. So I've done one. The second one, prototype is void number with 1 parameter called n1. Again, now it is saying find and display the sum of even digits in this particular problem statement. Okay, so they have given the number as 29865. All the even numbers are 2, 8, and 6, and those are added. We are finding the sum. So initially, we have to make a variable sum, the value of which will be 0. If they ask us to find the product, the initial value will be 1. If they ask us to find the sum, initial value will be 0. Number program. Now look how easy it is. It is based on the same logic as above. So we say while but the number here is n1. So we say while n1 is greater than 0, extract the last digit, which is always the modulus 10. Change the number is equal to n1 divided by 10. Fine. Now, what do we want to check with that digit? We want to check if that digit is an even number or not. So we say if that last digit divide or remainder by 2 gives us 0 remainder. Even numbers are divisible by 2 and the remainder is 0. So that is what we are testing here. If LD modulus 2 equals 0, then we will add it to the sum. Sum is equal to sum plus that particular last digit, which completes the looping part. The loop is to work on each digit. When do we want to print the sum? Do we want to print it every time we find a digit? No. We want to print the sum when we have finished checking all the digits. So remember, here in this case, the print statement will be outside of your while loop. And we will say system.out.println. The message given is here sum of even digits equals plus the sum. Variable sum holds the answer over here. And this is how we will write the second overloaded method. They now want us to create a main method and create an object of this. Okay, so there is another video on how to solve class-based programs where we create an object and call the methods. Same concept will be used here. So public static void main method. And first thing is create an object of the class. What is the class name? ex2 is the class name. Call the object as obj is equal to the new constructor, which is ex2. Same name as the class. Okay. Two methods are there. We can call both the methods. The first method is obj dot name of the method is number. But the first method needs two parameters. Okay. So you can use the example which they have given. Okay. Or if we have time, you can use scanner and take it. But for now, what we can do is obj.number and you can pass the number, which is any number like this. Okay. And the digit that you want to search. And I want to search for 5. So because this method has having two parameters, it will go up and search and say, I cannot call this one because this expects only one parameter. So I will call the first method, which is expecting two parameters. Call the second method obj.number. And now it wants only one parameter, which is a number. So I can put any number here. And that is enough for the main method. That completes the class. Okay. Every program, we need to write the variable description table. I'll just put a multi-line comment here to show the variable description table. What do we write in a variable description table? We write the variable, the data type of the variable, and the use or usage. What are the variables here? In the first method, num and d are the two variables. So we will say num, data type is int, uses the input number. D, again, data type is int, and this is the input digit to be searched. N1. Next method input parameter is N1 int, which is also just the input number. And finally, we have obj, which is of what data type? Data type ex2. Okay. And this is used to invoke the methods. And that completes the second example. We compile and see class compiled, new syntax errors. Okay, fine. So now program 2 is done. Last example for this case, problem statement 3. Again, it is from one of the past board papers, which says design a class to overload a function series as follows. 3 occurrences, void series with 2 integer parameters, void series with 1 parameter, void series with 0 parameters. So let's quickly get around to creating this class. No class name mentioned. I'll just use the program number, question 7. Edit this. Start with import java.util.scanner. and then start class question 7. 3 methods will be there. So the first method is void series int x comma int n. Remember, these are void methods, so they will be just printing whatever is required. If the data type was not void, we would have to return whatever is the data type mentioned. Okay. So here in this case, what is it asking us to do? To display the sum of the series given below. Sum, again, whenever we want to find sum, we make a variable sum. Initial value is 0. Okay. In this case, it might be better to take it as a long, okay, because you can see a number raised to something. Fine, it might lead to a number which is bigger than the capacity of int. So it would be good if we can use long. Byte, short, int, long are your 4 whole number data types or non-decimal data types. Byte is 1 byte, short is 2 byte, int is 4 byte, and long is 8 bytes. Byte, short, int, long. Okay. So now here again, this is a loop problem because you have to go on adding the sum. Okay. So what we will do for int I is equal to, what is changing here? What is fixed? X is fixed. Okay. The number here, the power is going on changing 1, 2, 3, and so on. Power is changing from, what is the starting? In a loop, we have to give the initial value. Initial value is 1. What is the last value? The condition. The last value is up to n. So that is what we will write here. I less than equal to n. How is the increment happening? 1, 2, 3. It is increasing by 1 every time. So we can write I plus plus in this case. Okay. In the loop, what we will do? The sum, we will first find the sum of this, add it to the sum. Next, we find this value and add it to the existing sum. This is how cumulative the sum will be calculated in a loop. So we write sum is equal to whatever is the existing sum plus. Now we will be using the math.pow function, and the math.pow function returns a double. We will have another small video on the math functions. Okay. So if it returns a double, but we want it to be a long, so we can cast it to a long. This is called type conversion. Now in bracket, what do we want? Math.power has what? The base. What is the base? Base is going to be x, whatever the user will pass the number in x. So base is x. What is going to be the power? Raised to 1, 2, 3, changes with every number. So what is that? That will be our I. Okay, I is going on changing with everything, and this is going to be how we will write this for loop. When do we want to print the sum? We want to print the sum once we have finished calculating it for all the occurrences here. Okay, so printing of the sum will be outside of the loop. System.out.println sum of series equals plus the variable sum. So it should be out of the double quotes. That completes the first method. Second method, again a series, void series, taking one parameter here, and it wants us to just display the series. It doesn't want us to find the sum. Note 2 ways. Here it's saying display the series, and here it is just put comma separated values. Okay. Now it is display. Again, we are displaying more than one. So the idea is there is going to be a loop. Okay. So, and we have to figure out what is the pattern here. Okay. So 0. Okay. The first number or the first number that we want to print is a 0. Okay. Let me see. Second number that we want to print at position 2 is a 7. Now I know 2 into 2 is 4 and 2 cube is 8. So this is 1 less than the cube. Let me see if that logic holds. At position 3, 3 cube is 27. One number minus 27 is 26. Okay. And for the first one, 1 cube is 1. Minus of 1 is 0. So, okay. So I have figured out what I have to print. Okay. And it is a loop. So for int I is equal to 1. First one. I less than equal to how many terms they want us printed? P terms. So I less than equal to P. The increase is first number here, second number, third number here. So it is I plus plus. Okay. Put a curly brace. What do we want to print? we want to print this. What did we find out? So we'll just do that, system.out.print. Okay. We want to print the cube of that particular position minus 1. So how is that? Cube of that number position is I into I into I minus of 1. Okay. So 1 cube minus 1, 0 will get printed. And there is a comma after that. So we will say plus in this a comma. And that is all we have to print, or that is all there is to this series problem. Okay. Third method is again void series with no parameters. Okay, fine. Display the sum of the series given below. Now again it is sum. So we have to initialize a variable to be 0. It is a what? 1 upon 2. What is 1 upon 2? 0.5. So remember, whenever there is division involved, the answer might be a decimal number. So the data type of our sum in this case should change to a double, and we will say the initial value is 0.0. Okay. Again, whenever we want to find the sum, it is a cumulative sum. We will first add this value to sum. Then we will add this value to the existing sum. Then we'll add the third value to the existing sum. So how many times we have to add values to the sum? What is fixed here? The numerator 1 is fixed. The denominator is changing. Okay. The denominator is starting from 2 and going up to 10. Okay. So whatever is changing will become our counter variable. So I will write for int I is equal to, what is the first denominator? 2. What is the last denominator? Less than equal to 10. Is it increasing by 1 every time? Yes. So I plus plus. Okay. Curly bracket. Sum is equal to sum plus 1 is fixed. Now, whenever we want to do division, at least 1, either the numerator or the denominator, should be a double or a number with a decimal point. So in this case, it is easiest, instead of 1, I will write it as 1.0. 1.0 divide by I. First value of I is 2. So it will be sum, existing sum is 0 plus 1 upon 2. Then it will be whatever is the existing sum plus 1 by 3 and so on. And that is all there is to this one. Again, sum, we want to print it, find the final sum at the end. So this is how we will write. And we will just say sum of series is equal to plus. That completes the third method with the same name. And that completes the class, as they have not asked us to write the main method. And compile here. Error is found in class. Semicolon was missing. Okay, fine. Class compile. Do note the variable sum here is a local variable. Local variable means it is declared inside this method series. So here this variable is applicable. The scope of this variable is from line 4 till line 10, till the method ends, from the method start to the method end. And hence, I can use the same variable name, long sum, on line 19 over here. I can use the same name because again, this is a local variable and the scope of this variable is in the method, third method here, which starts at line 18 and completes at line 20. Okay. This should be followed by your variable description table. By now we know variable description table. We need the variable, we need the data type and the usage. So for the first method, first variable is X. They have given you the data type int and that is the input number. The second is N. Again, the data type is int and that is giving you the number of terms. In the second method, the variable is P, okay, which is of type int. And again, it is P terms. So that is number of terms. Third method, there is no variable here. So we don't need to do it. We have used the sum variable once as a long, find sum of series, and once as a double to again find sum of series. This completes the session on method overloading. So hope you like the video and I'll see you in the next session.